Numbering. This tool provides automatic numbering of elements in the model. It offers three functions: quick numbering, typical numbering, and LAN numbering. Quick numbering enables fast, interactive numbering of selected elements. Typical numbering allows full flexibility in configuring numbering across the model. LAN numbering is dedicated to network sockets. Numbering is fast, consistent, and error-free, ideal wherever precise labeling is required. Let's showcase the quick numbering function using the numbering of the fire alarm system detectors. Let's launch the tool and review its interface. We see the starting number and a step of 1. If the step value were larger, for example 2, a separator would be used, but in our case, we will not be using it. Let's set the numbering restart at 10 to demonstrate how this works. We will enter the prefix PA and select the count prefix option, which means the prefix itself will be numbered. Let's start. Click the elements in sequence, and the program numbers them sequentially according to the defined settings. Now let's select the 10th element, the last in the series. The subsequent elements, as you can see, are numbered from the beginning, but with the PA2 prefix applied. Select the last element, press Escape, and the window will close. Ready. All elements are now numbered. Now, let's use the typical numbering function in practice. Let's start by drawing a line along which the numbering will take place. In this case, for the LAN sockets. The line does not need to pass exactly through the center of each element, as the tool automatically finds the sockets closest to the line. Let's proceed to launch the program and select the typical numbering function. The example is based on the active view. Elements have been retrieved from the active view. Let's select only the LAN sockets for numbering. Since the sockets are double, the step parameter is set to 2. After 24 ports, numbering restarts. Define the prefix value and enable count prefix to ensure automatic numbering. Now select the line. It is important to choose the first line that was drawn. Remember to enter the name of the parameter where the number will be written. Let's begin the numbering process. It's all set, but let's check if the result is correct. The numbering runs from 1 to 24, after which the prefix changed from P1 to P2, and the numbering restarts exactly as intended. Let's showcase the LAN numbering function. Remember, each socket must have a parameter assigned that specifies the number of ports. For example, 1, 2, or more. For the purpose of our example, sockets with the same number of ports are highlighted with the same color. Two areas are marked with a dashed line. The first area represents the first cabinet, and the second area, analogously, represents the second cabinet. Launch the program and select the first area. Elements within the indicated area have been found. Let's select them for numbering. Let's go to the settings and specify the parameter containing the number of ports. The remaining settings are the same as before. Now select the line. Again, it is important to choose the first line that was drawn. Let's begin the numbering process and proceed with checking the results. The numbers are exactly as set. For the double socket, we have numbers 1 to 2. A single number was assigned to the single socket. The socket with the parameter set to 4 ports received numbers 18 through 21. Everything was done correctly. Let's move on and indicate the second area. Let's change the prefix parameter and indicate the line along which the numbering will occur. Select elements in the second area for numbering, press and the numbering button. Let's verify the result. Sockets are numbered sequentially with respect to the number of ports declared in the specified parameter.